Hello student, today I want to present a chemistry lesson about water and hydrogen. This is a chemistry form 1 last topic, water and hydrogen. So we start first of all water. So as we see in the screen, water and hydrogen. Water is the most abundant substance on Earth's surface. About 71% is covered by water. Here now we have water covers about 71% on Earth's surface. Where can we get water? Water we can get from seas, from lakes, from river, from oceans. Other source of water, also water we can get from candle wax. When we burn candle wax, we get water. Remember, candle wax contains two elements, that is carbon and hydrogen, are the major component of organic matter. Organic matter burns in air to produce only two products. One is carbon dioxide gas, the other one is water. All organic substances, when they burn in air, they form two products, water and carbon dioxide gas. Candle is one of them. So when we reach Form 3 and that we call Organic Chemistry 1, and in Form 4 Organic Chemistry 2, we are going to learn more about organic matters. Candle wax is made up of organic matters. Candle wax is a compound of carbon and hydrogen. It belongs to a group of compounds called hydrocarbon. It burns in air to form carbon dioxide gas and water. So hydrocarbon are compounds that is made up of or consists of carbon and hydrogen. Example, we have candle wax. In example, you can be asked to define hydrocarbon. If they ask you to define hydrocarbon, you can simply say hydrocarbon are compounds that consist hydrogen and carbon. As the name states, hydrocarbon, hydrogen and carbon. So in simply we can say hydrocarbon are compounds that consist of hydrogen and carbon. We have other examples of hydrocarbon. There are many of them. Here I gave you these two: kerosene, petrol and diesel, and candle wax. Remember, we have said all organic matters, all hydrocarbons, when they burn in air, they produce two products, carbon dioxide gas and water. And hydrocarbons contain only two elements, carbon and hydrogen. Example, we have kerosene, petrol and diesel. So in exam you can be asked what product will form when diesel or when petrol burns. So you can simply say carbon dioxide and water. Also you can be asked, kerosene contains two elements, name them. These two elements are carbon and hydrogen. To demonstrate what happens when candle burns in air, this setup below can be used. Here now we have the candle. When we burn here, we see a burning candle. Remember, we have said that burning means combustion. Combustion is a process where substance combine with oxygen with production of heat. So oxygen is the active part of air that's about burning. When candle burns, it combines with air. It's bound to produce water and carbon dioxide gas. Water in form of steam or water in form of vapor plus the carbon dioxide gas passes through the delivery tubes. This is the delivery tubes. By now you must know the name of the apparatus. So here now we get, so this test tube A is deep into a cold water or ice. The role of ice cold water is to condense water vapor into liquid. So here now we observe a colorless liquid, and that colorless liquid is water. Then carbon dioxide gas also passes to the next delivery tubes, and we collect in the test tube B. Inside the test tube B we have calcium hydroxide, and our name is lime water. Then now we need now to see the role of ice cold water is to condense water vapor into liquid. In exam you can be asked, what are the tests of water? So we have said water has two tests, physical test and chemical test. Physical test of water is water has a boiling point. Pure water boils at 100 degrees centigrade, and pure water has a melting point of 0 degree. The chemical test, we use two substances, copper 2 sulfate. We use copper 2 sulfate, and then we use other substance called cobalt 2 chloride. Cobalt 2 chloride. Cobalt 2 chloride. So the colors are very important in chemistry. You must know the colors. When cobalt 2 sulfate, when it does not contain any water of crystallization, the color is white. The color is white. So we call it anhydrous white. The color is white, anhydrous cobalt 2 sulfate. But when we add to water, it becomes blue, hydrated cobalt 2 sulfate. So water turns white, anhydrous cobalt 2 sulfate, to blue, hydrated cobalt 2 sulfate. That is one chemical test of water. The other one is cobalt 2 chloride. When it does not contain water of crystallization, the color is blue in color. But after adding water, it turns to pink. So the other chemical test of water, we can say water turns blue anhydrous cobalt 2 sulfate to pink hydrated cobalt 2 sulfate. These are the two chemical tests of water. One, copper turns white cobalt 2 sulfate to blue hydrated cobalt 2 sulfate. The other one, water turns blue cobalt 2 chloride to pink hydrated cobalt 2 chloride. Then now the carbon dioxide gas is collected in the test tube B. Once the carbon dioxide gas reacts with or contact with calcium hydroxide, another name called lime water, they form a white precipitate. So the chemical test of carbon dioxide gas, we can say the carbon dioxide gas forms a white precipitate with lime water. In short, we write BBT. Remember in exam, we are not supposed to write BBT in short form. We write precipitate. So now we have learned that carbon dioxide gas has a chemical test. Chemical test for carbon dioxide gas, we use a substance called lime water. Another name is calcium hydroxide, as we see in this diagram. So we can say the chemical test of carbon dioxide gas is carbon dioxide gas forms a white precipitate with lime water, white precipitate with calcium hydroxide. Yeah, now we have in test tube A is deep into ice cold water. The role of this ice cold water is to condense water vapor into liquid, is to condense the steam into liquid. Observation and discussion. In test tube A, a colorless liquid is formed which turns white anhydrous cobalt 2 sulfate to blue and blue cobalt 2 chloride to pink. That's the chemical test of water. In test tube B, a white precipitate is formed. The white precipitate is carbon dioxide gas. When it reacts with lime water, it forms a white PBT. Remember in exam you can be asked what will you observe in test tube A? You said a colorless liquid is observed. They can be asked how can we test the water if the colorless liquid is water, so you use cobalt 2 sulfate, cobalt 2 chloride. Then they can be asked what will you observe in test tube B? You can simply say we observe a white precipitate because carbon dioxide gas reacts with calcium hydroxide, another name called lime water, to form calcium carbonate, which is an insoluble salt, and that is a white precipitate. Next, now we have in test tube, in candle wax burnt in air to form a colorless liquid which turns white anhydrous cobalt 2 sulfate to blue and blue cobalt 2 chloride to pink. The liquid is water. The colorless gas forms a white precipitate with lime water. Is also produced, and that gas is carbon dioxide gas or carbon dioxide gas. Next, now we go to reaction of water with metals. How metals react with water. General equation, you must know that metals, when it reacts with water, they form metal hydroxide and hydrogen gas. If you remember, we have said all metal oxide and metal hydroxide are classified as a base. So we can say when metal dissolve in water or when react with water, they form a base. The property of base is base turns red litmus paper to blue. Here now we have potassium and sodium. So this one reactivity series will help us. The most reactive element or the most reactive metal is potassium, followed by sodium, then calcium. This reactivity series is very important. Why is the potassium most reactive? That one we are going to discuss when we reach form 2 under the first topic. So potassium is the most reactive. We are going to look at the size the ease of losing electrons and so on. But now, when you are for money, you must know that potassium is the most reactive because it is the first element in the reactivity series, is the first one. If now this one you must cram the reactivity series, you can use this way. Please stop calling me a zebra. I truly like her calling me a super powerful giraffe. Or we can use popular scientists can make a zoo in low humid countries. So please stop calling me a zebra. I truly like her calling me a super powerful giraffe. So please, is potassium, stop is sodium, calling is calcium, me is magnesium, up to the end. So we're going to start sodium and potassium. They told us the reaction of potassium with water is very explosive. Since potassium is the most reactive metal, when it reacts with water, it is very, very explosive. The small piece of potassium placed on water melt into a silvery ball and move about rapidly on the surface. The reaction generates a lot of heat. As a result, hydrogen gas is produced. So we have said, when a piece of potassium placed on water melts into a silvery ball and move about rapidly on the earth's surface, of water, the reaction generates a lot of heat. As a result, hydrogen gas is produced. The flame produced here is a lilac in color. We call it a purple due to the presence of potassium vapor produced during the reaction. So the reaction of potassium with water, we have said, is very, very explosive. A small piece of potassium placed on water melts into a silvery ball and move about rapidly on the earth's surface. The reaction generates a lot of heat. As a result, hydrogen gas is produced. We have said potassium produces a lilac flame. Lilac means purple in color. The flame of potassium is purple or lilac due to the presence of potassium vapor producing during the reaction. Here we have the equation. Potassium plus water. Here there is an arrow. We have said an equation must have the reactant side and it must have the product side. Potassium plus water, we get potassium hydroxide plus hydrogen gas. The resulting solution turns red litmus paper to blue, showing that it's the basic. We have said metal oxide and metal hydroxide be classified as a base. So the resulting solution, which is potassium hydroxide, turns red litmus paper to blue, showing that it's the basic. Observation when we are using sodium. So we have said potassium is the most reactive metal. A small piece of potassium reacts with water. It reacts very explosively. Then sodium, we have said when a piece of sodium metal is placed in water, it melts into a silvery ball as it reacts vigorously, dating on the surface of water with a hissing sound. The resulting solution turns red litmus paper to blue, showing that it's a basic. So this can be the observation. Sometime in exam you can be asked, state or explain the observation made when a sodium metal reacts or placed in water. So we said it melts into a silvery ball as it reacts vigorously, dating on the surface of water with a hissing sound. The resulting solution turns red litmus paper blue, showing that it's a basic. And here we have the equation. Sodium plus water, we have sodium hydroxide plus hydrogen gas. This is our equation. So now I'm going to show you videos about when potassium reacts with water and when sodium reacts with water. So allow me to show you this video for the next minute, for the next 2 to 3 minutes. Let me first shrink myself for you to see the video in manner way. So this is the first video. Here we have, this now is potassium metal. Let us see together how it behaves.
Potassium metal, like all metals that are in group 1 of the periodic table, that's down the left hand side, are
Let's look
quite
it.
reactive with water. So imagine if you had some of this exposed in the laboratory and there was a fire and the fireman came and threw water on it.
I hope we are seeing this one. The flame now is a lilac flame. a small piece of potassium, when we place in water, it produces a lilac flame. You see, it reacts very explosively. I hope this one you are seeing very nice. It reacts very, very explosively. Let me repeat again the video once more. Let me repeat it once more.
Potassium metal, like all metals that are in group 1 of the periodic table, that's down the left-hand side, are quite reactive with water.
Unfortunately, in our lab, we don't have this potassium metal. That's why I'm trying to show you this video. You see the flame is lilac. Then it reacts very explosively as it produces a heating sound and it generates a lot of heat. So I hope this one we have done it. Then we continue. We want to show you now the sodium. Let me show you the sodium. When a piece of sodium is placed in water. Well, let's see the sodium metal. Let's see it together.
Potassium metal, like all metals that are in group 1 of the periodic table, that's down the left-hand side, are quite reactive with water.
You see?
So imagine if you had some of this exposed.
You see, it floats on the surface, on the surface of water as it produces a hissing sound. I hope you are seeing, you are hearing the hissing sound.
Reaction between potassium and water releases hydrogen.
When a piece of sodium is placed in water, it does on the surface of water as it produces a hissing sound. I hope you have seen this one. Let me repeat once more, once again. Then we continue. I hope you have seen when potassium reacts with water, and also when sodium reacts with water. We go to next now, calcium. Let me go to calcium. So calcium metal, when calcium is added to water, it sinks and react moderately with water. Remember, potassium, we have said it reacts very explosively as it produces a flame. The color of that flame is lilac or purple. Also, you have seen sodium, it floats on the surface of water as it produces a hissing sound. Calcium, it sinks. When calcium is added to water, it sinks and reacts moderately with water. And here we have the word equation: calcium plus water, we get calcium hydroxide plus hydrogen gas. Remember, our general equation, we have said metal reacts with water to form metal hydroxide and hydrogen gas. Magnesium reacts very slowly with cold water, while zinc and iron do not react. So here now we have the calcium metal, it sinks. If I ask you this gas, who knows this gas? That's very right. The gas is hydrogen gas, because we have said metal plus water, they form metal hydroxide plus hydrogen gas. So obviously this hydrogen is an hydrogen gas. Next time we go to now how we want to show you the calcium. How calcium reacts with water. Let me see if I have that video. It's here.
Drop calcium metal into.
Let me shrink myself first for you to see clearly.
Little puffs of gas being given off. What you're seeing is the water vapor.
You see, the calcium is in. The calcium sinks. It produces a colorless gas. You see, the colorless gas is hydrogen gas. It reacts moderately. It's not explosive. It's not vigorously. It reacts moderately. Our vision is very simple. So we continue. So we have done metal plus water. Next now we go to metal plus steam. How metals react with the steam. Here we have this diagram you are seeing on the screen. that here in the test tube we have a wet sand, we have a source of heat, we have a magnesium ribbon, and lastly we have cold water. So here you must heat the wet sand to generate steam. So the steam here, it reacts with a magnesium ribbon to form magnesium oxide plus hydrogen gas. I hope you are seeing this video, this diagram. First of all, they say you must heat the wet sand. I hope you are seeing this video, this diagram where a wet sand is generating heat, steam. The steam is react with magnesium ribbon. So magnesium plus steam, we get magnesium oxide, a white powder, plus hydrogen gas. So this gas become hydrogen gas. A wet sand is warmed to generate steam. A wet sand is warmed to generate steam, which react with metals. The delivery tubes is removed before the heating stop to prevent water being sucked into the gas into the hot boiling tubes as it cools. Observation: magnesium burns brightly in steam to form a white magnesium oxide powder and hydrogen gas. And here we have the word equation: magnesium plus steam, we get magnesium oxide plus hydrogen gas. Zinc and iron do not burn in steam. Instead, they glow. Zinc and iron, they glow. Zinc metal reacts with steam to form a yellow powder of zinc oxide, which turns white on cooling. So zinc oxide, when we cool it, the color is white. In hot, the color is yellow. Zinc plus steam, we have zinc oxide plus hydrogen gas. Ions form a black residue of an oxide called triion tetraoxide and hydrogen gas. Ion forms a black residue of oxide called triion tetraoxide, and here we have the equation: iron plus steam, we get triion tetraoxide plus hydrogen gas. Aluminium reacts with steam but quickly forms a layer of aluminum oxide, which prevents further reaction. So aluminium, immediately it turns to aluminum oxide, which prevents further reaction. So aluminium forms a protective layer which prevents further reaction. Lead and copper, since they are less reactive metals, do not react with either cold water and steam. Then now we have done metal plus steam. Next we go to hydrogen. I hope in Form 1 we have already discussed oxygen gas. Today we are discussing hydrogen gas. So the gases are very important. So hydrogen gas is the simplest and lightest element. It does not occur as a free on Earth's surface as a free element, but exists in combined form. Example of a compound containing hydrogen is water. Water, remember, we write as H2O, 2 hydrogen plus 1 oxygen atom, they form water. And remember, hydrocarbon, we have said, are compound that contains hydrogen and carbon, and also the sugar. So laboratory preparation and property of hydrogen gas. If I take you back, oxygen gas we can prepare in mostly 2 ways, or let me say 3 ways. By thermal decomposition of hydrogen peroxide in the presence of magnesium oxide, which acts as a catalyst. A catalyst is any substance that alters the rate of reaction. Also, we can prepare oxygen gas by adding water to solid sodium peroxide to form oxygen gas. So hydrogen gas is prepared in laboratory by the reaction between dilute acid and some metal. And that we call acid base indicator. We have learned one property of acid. Acid, when it reacts with metals, they form salt and hydrogen gas. Dilute sulfuric acid and hydrochloric acid react with some metal to liberate hydrogen gas. Zinc is the most suitable metal for laboratory preparation of hydrogen gas. And here we have the diagram. By now we must know the names of apparatus. Here we have the separating funnel, we have conical flask, we have delivery tubes, we have a gas, we have a trap containing water. Dilute hydrochloric acid, it's a dropping funnel, not separating funnel. As the name here, we have a dropping funnel. When the zinc granules react with dilute hydrochloric acid, they form zinc chloride, a salt plus hydrogen gas. So the salt remains here, The hydrogen, since a gas, passes through the delivery tubes and we collect by upper water. If you remember, oxygen gas we collect by upper water because the gas was slightly soluble in water. We have said the gases that are collected by upper water are either insoluble in water or slightly soluble in water. Hydrogen is insoluble in water, that's why we collect by upper water. Hydrogen is less denser than air. It can also be collected by upward delivery tubes. This method is also called downward displacement of water. So here we have three methods. This one is called over water. We have said that gases that is collected by over water are either insoluble in water or slightly soluble in water. That, for example, we have oxygen. The gases that we collect by upward delivery tubes are less denser than air. Example, we have hydrogen. They told us hydrogen is less denser than air. That's why we can collect by over water, by upward delivery tubes. At the same time, hydrogen gas, it is insoluble in water. We can collect by over water. We have another method. We call it a downward delivery tubes. When it is facing downward, we call it a downward delivery tubes. These gases, the gases that are collected by downward is denser than air. So these three methods. 1. Over water means the gas is either insoluble or slightly soluble in water. Upward means the gas is less denser than air, while downward means the gas is denser than air. We have done. Then how can we obtain dry hydrogen gas? We're using something called drying agent. Dry hydrogen gas can be obtained by passing through a wet hydrogen, by passing through anhydrous calcium chloride in a U-tube, apparatus called a U-tube, or by passing through concentrated sulfuric acid. By now you know that these are the two common drying agents. In laboratory, the common drying agent here are anhydrous calcium chloride and concentrated sulfuric acid. If you see this diagram of wet hydrogen, when we pass through a concentrated sulfuric acid, we get a dry hydrogen. Therefore, concentrated sulfuric acid and anhydrous calcium chloride act as a drying. The role is to dry the gas. When zinc granules are added to dilute hydrochloric acid, there is an effervescence. Hydrogen gas is evolved, and here we have the equation. Zinc plus hydrochloric acid, we have zinc chloride plus hydrogen gas. Nitrified acid not be used. It's not be used because the hydrogen produced is oxidized to water. They told us that nitrified acid cannot be used to prepare hydrogen gas because since this acid is a strong oxidizing agent, the hydrogen produced is oxidized to water. We're going to learn this acid and that to be called nitrogen and its compound in form 3 cos. So nitrified acid cannot be used because the hydrogen produced is oxidized to water. Instead of hydrogen we get water because the acid is a powerful oxidizing agent. The hydrogen produced is oxidized to water. But when it's very diluted, we can use with magnesium to form hydrogen gas. Zinc is preferable because zinc reacts moderately with dilute acid. The more reactive elements such as potassium, sodium, lithium and calcium react very explosively with dilute acid, hence must not be used. If potassium plus water is very explosive, what about potassium plus acid? You see, potassium, sodium, lithium and calcium, the more reactive element, more reactive metal, they react explosively with dilute acid, therefore must not be used. Magnesium could be used. You can use magnesium to prepare hydrogen gas, but remember magnesium is very expensive. The cost is very expensive. Aluminum forms a protective layer of aluminum oxide which should be washed during using concentrated hydrochloric acid before use. Aluminum forms a protective layer which prevents further reaction. Impure ion gives a mix of gases including a bad smelling hydrogen sulfide gas. This gas called hydrogen sulfide gas has a bad smelling. So impure ion must not be used because it gives a mix of gases including a bad smelling hydrogen sulfide gas. Next, now we go to physical property of hydrogen. Hydrogen is a colorless gas, just like oxygen. If I take back to oxygen, we have said oxygen is a colorless gas or odorless gas, slightly soluble in water. Remember, hydrogen is also a colorless gas or odorless gas. Odorless means smellless gas. It's less denser than air and it's insoluble in water. Hydrogen gas has no effect on litmus paper, that's why it's a neutral. Then next we go to test of hydrogen gas. Test for hydrogen gas. You must know the test of oxygen gas. Oxygen gas, we have said oxygen gas produce or oxygen gas release a glowing splint. And remember, hydrogen gas produce a pop sound with a burning splint. A pop sound with a burning splint. This is a test for hydrogen gas. Hydrogen gas produce a pop sound with a burning splint. Pure hydrogen burns quietly with a blue flame. So hydrogen, the flame it produces a blue. Hydrogen does not support combustion, means burning. Hydrogen does not support burning, but it burns in air. Next, now we go to reducing property of hydrogen. Hydrogen is a strong reducing agent. Reducing agents are those agents that have the ability, capable of removing oxygen from other substance. It can reduce some metal oxide to their respective metals and itself oxidize to water. Here now we have this experiment. Dry hydrogen, when it reacts with, when it passes over heated cobalt oxide, this, the color of this one is black. I told you the colors are very important in chemistry. So the color of cobalt oxide is black. When you remove the oxide, it becomes copper metal and the color is red brown. So when cobalt oxide reacts with hydrogen, hydrogen has the ability to remove the oxide. So hydrogen remove oxide from cobalt oxide, itself oxidizes to form water. Hydrogen plus oxygen we get water, and copper reduces to form copper metal. So the water, when it contact with anhydrous cobalt sulfate, remember the chemical test of water, we have said water forms white anhydrous cobalt sulfate to blue. So once the color here we observe a blue, the white anhydrous cobalt sulfate turns to hydrated cobalt sulfate. And also we have learned that hydrogen burns with a blue flame. So here now we observe three observations. One, cobalt oxide, the black cobalt oxide turns to red brown copper metal because hydrogen reduces cobalt oxide to copper metal. The other one, now hydrogen itself oxidizes, it reacts with oxygen to form water. So here the next observation, we observe anhydrous, white anhydrous cobalt sulfate turns to blue hydrated cobalt sulfate. And lastly we observe a blue flame. In example can be asked, state three observations under this setup. One, black cobalt oxide turns to red brown black cobalt oxide turns red brown to copper metal. Anhydrous cobalt sulfate turns to blue, from white to blue, and lastly hydrogen burns with a blue flame. And here is now the observation. On passing a stream of dry hydrogen gas over heated cobalt oxide, the black cobalt oxide changed to red brown. At the same time, a colorless liquid condenses and collects on the cooler part of combustion tube. Hydrogen combines with oxygen from cobalt oxide to form water, which forms a colorless liquid. The red brown solid is copper metal. And here we have the body question. Cobalt oxide plus hydrogen, we have copper metal plus water. So here now cobalt oxide reduces to form copper metal and hydrogen oxidizes to form water. Therefore hydrogen has the ability to remove oxygen from cobalt oxide. Therefore hydrogen becomes reducing agent. In other words, in other hand, we can say cobalt oxide gives oxygen to hydrogen. Therefore cobalt oxide is an oxidizing agent. In this reaction, cobalt oxide is reduced to copper metal while hydrogen oxidizes to form water. Hydrogen remove oxygen from cobalt oxide, and therefore we call it reducing agent. Whereas cobalt oxide loses oxygen to hydrogen, or it gives oxygen to hydrogen, and therefore we call it oxidizing agent. Another way, now hydrogen will also reduce the oxide of lead and iron, less reactive metal, such as lead 2 oxide plus hydrogen, we get lead metal plus water. Iron 3 oxide plus hydrogen, we get iron metal plus water. Hydrogen does not remove oxygen does not remove oxygen from oxide of more reactive metals such as potassium, calcium, lithium, and sodium. Those are the more reactive metal. Hydrogen cannot remove it. Next, now we have another diagram burning of hydrogen gas. Here now we have hydrogen from generator. When it passes, this apparatus is called a U-tube. It looks like a U. See? When the wet hydrogen is passing through a U-tube containing anhydrous calcium chloride, we get a dry. Remember, this one we have said is a drying agent. Commonly drying agents that can be used in laboratory are two. One is anhydrous calcium chloride, the other one is concentrated sulfuric acid. Both of them, their role is to dry the gas, act as a drying agent. So when hydrogen burns in air, we have said it combined with oxygen. Hydrogen plus oxygen, they form water in steam. That's why water we write as H2O. So the steam passes through the delivery tubes and we collect in the test tube here. We have said in chemistry, we see a ice cold water, the role is to condense the steam into liquid form. Therefore, this colorless gas, this colorless liquid is water. Is water because oxygen plus hydrogen we get water, and the chemical test of water we have said water turns white cobalt 2 sulfate to blue hydrated cobalt 2 sulfate. Also, water turns blue cobalt 2 chloride to white. That's the chemical test. And the physical test we have said water. The physical test of water has a boiling water. Pure water has a boiling point of 100. Pure water has a melting point of 0 degree. Anhydrous calcium chloride is used to dry the gas. The ice cold water is to condense the steam into liquid form. When hydrogen burns in air, a colorless liquid is formed which turns white anhydrous cobalt 2 sulfate to blue. The liquid is water, and here we have the equation: hydrogen plus oxygen, they form hydrogen oxide, which simply means water. Lastly, now we go to uses of hydrogen. 1. Hydrogen is used in large-scale manufacture of ammonia in a process called HAPA process. God willing, when you reach to Form 3 and a topic called nitrogen compound, we are going to learn a flowchart, a whole process called HAPA process, large-scale manufacture of ammonia, which we call it a HAPA process. Hydrogen and nitrogen we use as raw materials. So hydrogen is used in a large-scale manufacture of ammonia in a process called HAPA process. 2. The gas is used during hardening of oil to form fat. When hydrogen passes through liquid oil in the presence of a nickel catalyst, the oil takes up hydrogen and it converts into fat. The process is called hydrogenation. Also, this process is under to be called organic chemistry 1. We are going to discuss when we reach Form 3. Hydrogenation is adding of hydrogen. In the presence of a nickel catalyst, the oil remember is in form of liquid and fat is in form of solid. So oil is converted to fats in solid form by a process called hydrogenation in the presence of a nickel catalyst. Number 3, we have hydrogen is used in the balloons because it's lighter than air. A balloon filled with hydrogen floats on air. A light radio instrument can be connected to the balloons to collect information from the atmosphere. Number 4, a mix of hydrogen and oxygen burns to produce very hot flame, the oxyhydrogen flame, which has a temperature of about 2000 degrees centigrade. The flame is used in welding and for cutting metals. Also, if you remember, oxygen is used for welding. So oxygen plus hydrogen, they form oxyhydrogen flame, which is used in welding and cutting metals. Number 5, hydrogen is used in the rocket as a fuel. Hydrogen is used in the manufacture of hydrochloric acid, and hydrogen is used as a fuel in a fuel cell just like oxygen. So I want to end this video by asking these 5 questions, quizzes. 1. Define hydrocarbon. 2. Give 3 examples of hydrocarbon. 3. What products will form when kerosene burnt in air? State the test of hydrogen gas. 5. State and explain when the following methods react with water. Describe, always say, discuss the observation when sodium reacts with water, when potassium reacts with water, when calcium reacts with water. And that's the end. But I want to summarize what we have learned today. Today we have learned a topic from one topic called water and hydrogen. We have said water is the most abundant substance on Earth's surface. About 1% on Earth's surface is covered by water. We can get from seas, rivers, lakes, and so on. But we can get by burning candle. When we burn all organic substance, they produce water and carbon dioxide gas. When we burn candle, remember candle belongs to a group of hydrocarbon, a group of compound called hydrocarbon. You see, compound is a pure substance that's made up of two or more elements chemically combined. So we can see hydrocarbons, when they burn in air, they perform carbon dioxide gas and water. So what the hydrocarbon is? You say hydrocarbon are compound made up of carbon and hydrogen. Example, we have candle wax, petrol, diesel, crude oil, and so on. There are many of them. All organic matters, when they decompose, when they burn in air, they produce only two products, water and carbon dioxide gas. Hydrocarbons contain two elements, carbon and hydrogen gas. Diesel or petrol, when we burn, they form carbon dioxide gas and water. It contains two elements, that is hydrogen and carbon dioxide gas. Then we have learned what happens when metal reacts with water. The most reactive metal is potassium. Potassium, we have said, potassium is the most reactive metal. When it reacts, a small piece of potassium, when we place in water, it reacts explosively. It generates a lot of heat as it burns. So the flame here is a lilac or purple in color. Potassium, when we place a potassium on water, it does on the surface water as it produces a hissing sound. The resulting solution is basic. It turns blue. I'm sorry, it must be to blue. We have said in general equation, remember, we have said when metal reacts with water, they form metal hydroxide plus hydrogen gas. Calcium, we have said, it sings. Also, it produces hydrogen gas, and now the solution is a basic. Then we have learned when metal reacts with steam. Example, we have taken magnesium plus steam, they form magnesium oxide plus hydrogen gas. Also, we have discussed hydrogen gas. We have said hydrogen gas is the lightest element. In fact, when we reach from 2 first topic, we are going to discuss the structure of atom, structure and the property of atom, and the periodic table. The first element in the periodic table, in the modern periodic table, is hydrogen. So hydrogen gas can be prepared by reaction of zinc plus hydrochloric acid to form zinc chloride plus hydrogen gas. Zinc is the most suitable metal because it reacts moderately. They told us nitric acid cannot be used because since it's a powerful oxidation agent, the hydrogen produced is oxidized to form water. They also told us that potassium, calcium, lithium, and sodium, since they are more reactive elements, they react explosively with acid. Magnesium could be used, but remember, magnesium is very expensive. Aluminium form a protective layer of aluminum oxide which prevents further reaction. Impure ions produce a mixture of gases which include one gas which has a bad smelling hydrogen sulfide gas. Also, we have discussed that hydrogen is a reducing agent. It can use less reactive metal from the oxide of less reactive metal and it self-oxidizes to form water. And lastly, we have discussed the property of hydrogen gas. Hydrogen gas is a colorless gas or odorless gas insoluble in water, and also we have said the gas is slightly soluble, it's less soluble, it's less dense than air. The test of gas, the gas is tested by it produce a bob sound with a burning splint. So, and lastly, we have discussed the uses of now hydrogen gas. One, we have said hydrogen gas is used in the manufacture of hydrochloric acid. Hydrogen gas is used in large-scale manufacture of ammonia, a process called Haber process. Hydrogen is also used a process called hydrogenation to make fat, to make oil in liquid form, to make oil in fats. A process called hydrogenation in the presence of a nickel catalyst. Hydrogen is used in welding together with oxygen gas. Hydrogen is also used in a fuel cell. We can now say that is the end of my video today. So Wish you good luck.